Hello and welcome everybody. Today's webinar topic on automated machine monitoring program is going to be presented by our industry peers Brian Borg and Greg Beecham. They're both condition monitoring specialists from InfraBuild Steel, formerly Liberty One Steel. In this webinar, Brian and Greg are going to share with us their digitalization journey and how they have seen tangible benefits by automating their machine monitoring program. So while others talk of inevitable cause and effects, these guys have found ways to determine the cause early enough to decide its effect. So the webinar is going to be run for 45 minutes with about 15 minutes allocated at the end for any question and answers. We encourage you guys to submit your questions through the chat window at any time. The presenters obviously will do their best to answer as many as they can. It's advisable that you include your name and company name when submitting your questions, so we can even try to respond to you during or after the webinar. So lastly, we appreciate if everyone can switch off your microphones and videos during the webinar. And those of you just joining in, welcome again. I'm now going to hand over to Vish Arora from SKF, who will facilitate this discussion today. Thanks.
Thank you, Ashim. A very good morning to all. I'm Vish from SKF. So I'll be steering this conversation today, guys, and I hope I do a good job for all of you. So why we are all here, as Hashim said, we are going to understand how automated machine monitoring program has created reliable partnership between operations and maintenance for InfraBuild. We've got industry experts from InfraBuild, Greg and Brian, who will be taking this discussion on. So let me quickly get Greg into the picture. So Greg, if you don't mind, might give a quick brief introduction and tell us a bit more about InfraBuild. Sorry, Greg, the famous, you're on mute.
Novice. Currently, I've been here at One Steel / Liberty Steel / InfraBuild for roughly 10 years as a CM technician. Basically looking after the rolling mill here at Newcastle. We roll rod mill up here. So yeah, it's high speed steel, high speed rolling, and it can be quite challenging at times to diagnose faults in gearboxes and so forth. So, but where we're actually at, I was actually asked to give a bit of a rundown where we actually came from or where we are. So about some of our businesses are over 100 years old. We're actually part of a large group that was once BHP, split off from One Steel to BlueScope, and then the One Steel business primarily looked after all the rolling, the bar, the rod, and the structural type steel, whereas BlueScope went into other areas using plate. So One Steel, for many years, was ran the business. Then we were taken over by the Liberty Group, and we're now InfraBuild.
Perfect.
The InfraBuild.
Sorry, go for it, Greg. I was just going to say, what does your footprint across Australia looks like?
Yeah, no worries. Well, the InfraBuild business is compromises of the rod and bar group, which are primarily the Newcastle rod mill, Sydney rolling mill, and the Laverton rolling mill. We also have wire, pipe, and a huge distribution network that are all looked after around, so we actually supply steel to the Australian market. We're also one of the trusted brands, I'll just name one of them, that we actually roll steel for is the Waratah brand. So the rural pickets, the wire, everything and that's come through our business and is marketed as the Waratah brand. So those people out there in the rural industry will understand that that's been around for a long, long time and is actually a trusted product on the market.
Perfect.
So that's our business in an overview, basically. Yeah.
Great. So now, as we've understood, there's a great range of products and steel goods which you do. When it comes to manufacturing, how does InfraBuild goes about achieving or successfully delivering reliable operations? How do you guys go about that?
Well, again, I've got to turn time back. It was back when One Steel was first formed after the split from BHP. A senior group of engineering was put together as created a group known as OPEX, which was Operational Excellence. There were subject matters from electrical, mechanical, lubrication, structural, cranes, and CM. So they actually all put together as a large group, and they had a mandate to basically educate and change the cultural difference to in the business to actually look at reliability as an asset, not as a cost factor.
Absolutely.
So from there, we've actually been able to, and the group, I was talking to some people that were actually back in that group many years ago, and they tried to look at reliability as equivalent to safety. So we actually look at safety of our people. We actually look at safety of our gearboxes and equipment. Therefore, we actually treat them with the same kind of respect and along those lines. So we actually have reliable plant, you know what I mean? So we don't hurt anyone. We don't want to break any equipment. So it comes along the same sort of difference around that.
Now, great analogy, Greg. Good to know that if reliability can be looked at as safety, and you take care of the machines and machine take care of you and the production, I think that's the way it should be. Great, brilliant.
Yeah.
Thank you for an overview, Mike. Now let me get Brian Borg in. So Brian, from your insight, I see you're based in Laverton. Where do we start? Where do we start this journey of reliability, condition-based maintenance? Where do you start?
Okay, so the journey started with OPEX as well, the same as Greg. Around the same time, would have been about 11 years ago, we were approached by the OPEX group to start a CM program. I applied for the job, got the job, and had a few mentors come in and help us set up. So the best way to describe how we started was to go back and look at historical delays or breakdowns that we'd had. And what the OPEX group was able to do with all that data was to create a register of all our equipment and rate them for criticality. So they rated the criticality depending on how long the business would be down for and how much money lost if that particular machine broke down or had issues. And they developed a software program that we still use today, which is a OneCare program. And that's just a platform to enter all the data for the tests that we collect. As you can see on the slide there, there's also risk ratings for each measurement that we take.
Absolutely.
And there's also classifications on what the equipment is classed as. So if we have something that would stop the business for a day or 5 days, it would go into its own class. If there's something that is has redundancy, like a pump or something like that, it would go in a lower scale.
Perfect. So now, great, we've got a list of assets. We've understood how they operate, what their history looks like, and what consequence it can do. But again, then thinking about, okay, fine, we definitely need to do something about these assets. So that's very clear. But then how do you select what technology? So how you are getting data of these assets?
Okay, so sorry, I missed the introduction bit. I'm Brian Borg. I look after the rolling mills condition monitoring at Laverton. We have 2 mills there. We have a bar mill and a rod mill, and we have over 1,200 assets that we look after across the 2 mills. Running the program that we did with OneCare guiding what tests we do when we do them. We have over 93% compliance with all the tests that we need to do. We have around about 8,500 condition monitoring related tests. The data's all there on how they're sort of split up. Inspections and major inspections during shutdowns are actually part of our list as well. We have a lot of that 286,000 shift inspections. So we have a digital inspection that is done every shift, so twice a day, and there's a lot of data that comes out of that in terms of a shift fitter walking around and just monitoring the equipment like a millwright would do or used to do. We do our own in-house oil analysis, so patch testing of our oil. We do our own precision engineering, so alignments and precision engineering on our mandrels that go onto our gearboxes. We also do online and offline vibration analysis ourselves, in-house thermography, both electrical and mechanical. And we've got a system that we've developed with the use of the SKF software, which is an early warning device, you could call it, that starts screaming no matter what the hour is if there's an issue with a particular piece of equipment that we're monitoring online. I've named it a watchdog program because that's what its intent was, was to just start yelling if something was going wrong. Yeah, I think we go to the next slide now, Bish.
Just before we go to the next slide, Brian, very interesting to see, like when I go into the industry and see other organizations embarking this journey similarly as what you've said, this is a hell lot of data, 1,200 plus assets, 8,400 plus bloody tests. How do you correlate all of this data, or is there a correlation happening? I would be really keen to know.
Yeah, there is. Like I said, every measurement that we take, we have an overall value, and we enter that into OneCare. OneCare spits out a report once a month, and which goes to the general manager. So any equipment that is listed by us that has an issue or that needs repairing, we basically put in a corrective action based on our findings. That corrective action gets made into a task for the maintainers, and that report goes to the management, so the management know that that piece of equipment is not as healthy as what it could be.
Absolutely interesting. What happens if the task or the skill required to that task, who manages that? So obviously you've done your job well by identifying and notifying. I'm still missing what happens if you said something to be done, but the person going to do that is not skilled enough. Is there a control there?
The skilled part of it, I actually have a bit of a hand in it as well, because I'm the maintenance trainer as well. So we, if we do have a skills gap there, we try to fill that up as well.
Absolutely.
And we tend to, depending on what the issue is or what the repair is, we tend to put the right person on the job most of the time.
Perfect.
There's also another part of this, is that once the corrective action has been made, they've all the maintainers have been trained to set the CM department a retest task as well. So until the retest task comes back as good condition, then the machine doesn't come off the list. So
verification, very important, yeah?
Yes, you have to follow it up. Anyone that knows me at Laverton site knows I follow it to the end. So
yeah, valid point.
Until, yeah, like I said, until I can actually hand on heart say that machine is back to normal, then it doesn't come off the list.
Perfect. So now we've got all the metrics and the condition data and the performance data for the machines at one place. How do you measure your condition monitoring program? So you said 93% compliance. How do we achieve that, or how do we know it's achieving that?
Okay, so we have a number of tests that we are supposed to, as you can see in that top left-hand corner there. We have a number of tests. So a machine may be deemed that it requires vibration monitoring, oil analysis, and thermography once a month, every 4 weeks. This report actually looks at that and says, yes, the data was entered for that month for that machine, so it's in the green. The test was done.
Okay, so that's the first part. Yep.
So there's a figure there that says that we've achieved 90% of our program, or 93%, whatever. You can never really achieve 100% because you have a lot of machinery that is sitting idle and you can't test it.
Yep.
Yeah, so anything, I was told when we first started, anything over 75% was great. So we've constantly, as you can see from that top left slide there, we do the same work every month. We've got the same amount of machinery that is sitting idle. You could go around and start all those machines and get a test and things like that, but it's not easy while production is running.
Yeah, definitely. One good part here, Brian, what I have really noticed is the abnormal condition, or let's call the failure modes, and it's picking up how many faults are happening when and in what area. So how I see it is, it's brilliant that you'll exactly know what is that 20% of the pain child's causing you bloody 80% of the pain and the downtime. So definitely very fruitful.
When we enter data in, it's not as simple as saying there's something wrong with the machine. You actually have to, from an analyst point of view, determine what the cause is or what the problem is, which makes it a lot easier for you to raise a corrective action and direct it to where it needs to be done.
Absolutely. Guys, we could keep going, but while we are at this slide, and this is sort of an holistic view, what I understand from the audience, has anybody got any insights, questions, or anybody wants to pick up one point? I'll just give one person to come up at the moment, because obviously we're not supposed to do it, but it's so interesting I couldn't hold myself back. So I'll just open the floor for a second if somebody has got an insight or a question popping up right now. Perfect. Silence is good here. So guys, we've understood what you're doing overall in achieving reliable operations. We've understood how the condition monitoring program has started, how it is performing. Let us drill a bit more further, because I still want to get convinced. How do you do? What do you do? Can you share a case with me if possible?
Yeah, sure. Okay. So this problem is very recent. It's only a couple of weeks old. It's easy in our business to find a case where we have had an influence there, because it happens on a daily basis. So the problem was our combustion air fan, which feeds fresh air into our furnace, reheat furnace for the bar mill. It had a history of having a bearing defect or bearings becoming loose. They're on a taper lock, and the taper lock sometimes gives way and makes the bearing loose. So we had the machine was actually on a monthly handheld schedule. So we'd only just previously done that something like 6 days before the issue developed. So we weren't due to go back there for another month. A shift fitter during his checks noticed that it was starting to make an abnormal noise. We then went down the line of trying to keep it running. We couldn't stop the mill. It was going to cost us 72 hours of unplanned delays. It sounded really, really bad, but we weren't sure if it was getting worse. And on that same day, I asked to get another measurement. 6 hours later, and the thing had tripled in vibration.
Wow. Okay.
No one would really want to pull a pin on stopping the mill for 72 hours, so we had to try and think on our feet. I had a spare SKF IMX sitting in my office, and
what sort of IMX was it, Brian?
It was an IMX 8.
Okay.
Yeah, so we've pretty much that's what we use on all our online equipment, the ones that are hardwired in. I had a spare one there, so I deployed it and put it into a portable box, you could say. Ran some power to it, connected it to the online software, and we were able to take readings every minute.
That was handy.
Yeah. So watching that over the next few hours, we saw that the actual machine, although it was very high, had stabilized and it wasn't getting any worse. Which meant that other things weren't being affected. The fan wasn't starting to rub or anything. We could see all that now. We could also see the motor wasn't really too fussed. So we decided to just monitor it. I set alarms that would email me if something got worse. And we continued until the down day, and it was like production didn't miss a beat. They didn't even know anything was wrong, really.
Perfect.
Yeah, so it was a really good sort of outcome for that sort type of failure.
Classic example for a job well done, isn't it?
Yeah, well, we'll be doing that sort of stuff a lot more in the future now that we can do it.
Absolutely. So when we talk about savings, obviously having that IMX, putting it into a portable box because you weren't aware of what can happen. So I understand the gist. We were trying to save a catastrophic failure to happen and also not to stop the flat fan because it may have costed unplanned downtime and production losses. But if you were supposed to get a new kit build up for a new asset, how do you sell this kit to your management? How do you convince internally that, okay, we want this on this asset?
Oh, well, basically, we've been running at the first 8 years or so out of the introduction of CM. It's basically just going off history.
Mm-hmm.
So as soon as a machine breaks down, typically they would let me put a unit on that machine.
Okay, so the value is already justified in this case.
Exactly, yeah. So recently, the last 3 or 4 years, it's been no issue for me to justify any part of CM. We've had enough hits and enough misses now to justify doing whatever we think we need to do. A lot of it was deemed at the start as overkill.
Yep.
But as soon as you pick up a bearing on that particular machine, and if people realise if we didn't have this, we would have stopped. That justification is already in the bank, So
absolutely,
it's a lot easier now.
Money saved is money earned, mate. Yeah, very well saying that. Now, thank you, Brian.
Not very easy for anyone listening there to justify how much money you can save.
Yeah.
But yeah, at the end of the day, when you look at the bank balance, we know that we're way in front. But we've got a lot of history. As Greg said, there's 100 years worth of history in breaking stuff. Our industry, it's not whether you break stuff, it's just how long before the next one. Yeah, so there's a lot of justification there.
Absolutely. Now, thank you, Brian. Lovely share. Let me get Greg back in here. Greg, is there a similar sort of scenario at your site as well? Because I know Brian's from Laverton, you're from Newcastle. It was interesting to see how Brian pitched off a Conmon system having this value. Obviously, you also gave us a great overview of what Conmon can achieve and how reliability is taken as a safety. But do you have a share from your side or your end as well?
Yeah, well, basically, from what Brian was saying, he adapted an online system that we usually have hardwired into being able to use it as a portable system, simply because he had it there available to use it, and we were able to do that. But for those people who haven't got a online system yet, I've used a example here of on a monthly basis, we take data on this pump. It's a high pressure pump. It's roughly around about puts out about 1,200 to 1,300 kilopascals of water pressure. It's a 4-stage vertical pump, so it's quite a hefty bit of gear. I do it on a monthly basis, go around, check it. And for this instance, it was one of those things where we've actually had one of these fail. And ultimately, to take it out, put it in place, we've got redundancy having a second pump there, but ultimately it's a $100,000 rebuild.
Wow.
And for basically a $2,000 bearing. So we've progressively moving to putting a lot of this stuff online. It's not as fast as we would like, obviously, but so we still do a programmed maintenance check every month, go around to VA, thermo, and just a check on the oil. But in this instance, I'd been monitoring a slight change in the high-end frequency early warning stuff envelope, and basically that went on for 2 months, and I was very cautious because I know these pumps, they've got about probably 2 tons sitting on a bearing in a vertical format, so there's not much room for any starts to fail. It goes very quickly, and we are down for a lot of money. So basically, as soon as the data changed in the handheld, taking handheld data, I monitored it more often, and it was very quickly to me to say, look, we're going to have to get in and do this straight away. So rather than we instigated a change out on the bearing. So ultimately, by pulling it out, changing the bearing, realigning it so it's all back in, because I do all that here on site myself, like Brian, and setting it all back up. So we averted a catastrophic failure, which we've had in the past, where it cost in excess of $100,000 to replace this pump because it's ceramic coated and so forth. That's cost us $5,000. Wow. So Brian's talking about an ICE2 here on site have online VA, so I can actually, it's monitoring it every 15 minutes. So I can see the loading change in the mill and everything else. But this is going back to bare basics, doing the handheld stuff, looking at the equipment, and you can't take away the old sight, smell, hear, and feel. That's getting back to bare basics for CM. And history also comes into it as well. Once you've learnt, your equipment, but it definitely saved us a lot of money here on site for $5,000 compared to a $100,000 change out. That was quite a significant win.
Definitely. Greg, we've seen in industry that many times what the end users do is get suppliers or, let's say, third-party contractors engaged who are apparently subject matter experts and give them the right condition assessment. And for example, contractors coming in on a frequent defined frequency, taking readings, giving reports, and similarly other mechanical teams coming, fixing stuff. In contrary, I see you've got a lot of technology in-house. Do you find a difference? Was InfraBuild's approach ever like, shut shop reliability, let's outsource everything, let external people come and do stuff, work for us, versus now you guys sitting here? Obviously, hard question, but have you had that battle internally ever?
Definitely. I've at one stage there, we were judged upon using the One Care report. We were actually judged upon what we were actually doing. And when we were before the OPEX group was disbanded and One Steel changed to Liberty, and there was all the upheaval within the business, we were actually questioned about our ability of why we're actually doing the jobs, simply because someone from a higher level looked at the accounting side of it and looked at the hours booked against work orders. And because the work orders were set up on a different plant, we were working in that plant, the hours weren't actually booked against it properly. And we got looked at as though, well, what are we doing? You're not doing the work. But from accountability, but then we sort of reached out and said, hang on, look at this. And we actually we justified our cause, and therefore we're still within the business. But Absolutely. Yeah, it's very easy for someone to look at the dollars and cents for certain things within the business, now whether it be, but ultimately your equipment is going to cost you. Obviously, we have equipment that's redundant. You have small pumps that might only get looked at once every 3 months because they are redundant, they're small and low cost. But some of this bigger stuff, it's not till a CM person would walk away from the business that's actually entrenched into a business like we are, that you'd 6 to 8 months, then you'd start to see failures, because contractors come in, they look, they don't know the history of your machinery. They'll give you an advice on what they see on a chart on a wall or their own history, but quite often they won't know the machinery intimately as though you would as if you walk past it every day. And I feel that having an in-house CM program, whether it be overseen or integral part of the business by someone in the business, it's a mandatory thing, basically.
Absolutely. Now, just pulling again, Brian, back yourself. You've done that. I'd heard how you were hired when the whole One Care program was getting set up and the overall program was starting, and you've seen it basically from ground below coming up and growing into this flourishing tree now, what you've achieved. How has technology evolved in all of this time, Brian? So what was before when you started versus what is now? Has there been a change, and do you see value with it now?
Yeah, of course. Look, it's pretty incredible of how much it's advanced in the last 10 years. I mean, we started off collecting data on different products, depending on when we were allowed to go into the mill by production. We quickly found out that we have a lot of variables in our business. There's, if you can imagine running a car through a set of rollers every couple of minutes, that's what we do. That's where our equipment goes through. Sometimes they're small cars, sometimes they're trucks. So there's a lot of variable issues. We quickly found out that if you set alarms based on an average across all products, that you could easily lose something on a soft rolling product, we'll call it that, because it was never going to break an alarm which is set for a higher stressed out product. So with the technology now that we use the Observer software, and this is where the Watchdog program comes into it. We have alarms based on the product that we're rolling for the day. So as soon as they change to another product, the software quickly adjusts the alarms based on that product. So we're now able to, I spend 99% of my day pulling production up and saying, what are you doing? What's the difference today? What's wrong? And usually it's nothing and there's nothing wrong. Then all of a sudden they'll have a stoppage for something else to go and make an adjustment, and then the alarm comes back to green.
Okay, so more operational rather than condition.
Very much so operational. I mean, I can now trust these alarms wholeheartedly. It took a very long time, and I just said to someone yesterday that if I was to lose the work that I've put into this software program over the last 5 years, I would probably hang myself, because I'd never be able to do it again from scratch.
Strong opinion.
With the learnings, you know.
Yeah.
Could I interject there as well? Basically, I'm following on the footsteps of Brian in regards to this. We've changed from having another software platform and came over to SKF here on site. And basically, again, we used to take product-related VA. Now we've got the online system. I've got it become so entrenched within the operators that I can walk up to the operators and just talk to them and say, listen, I'm starting to get a warning alarm. I'm not going to high alarm, but I reckon you're putting too much product through these rolls. I need to get you to adjust it further back. And I've got a great now rapport with these guys on each of the shifts that are here, that I can walk up and do that. And basically all I'm doing is taking the load and making the longevity into the actual equipment, because if they rolled for 24 hours on one product and we missed that by taking data on the Monday, and it was the following Monday we're taking data again, they rolled 24 hours with this high load and being too rough on the gearbox, basically, that we'll actually start to see next time we take it, bearing faults and cage faults and things like that. And you go, well, how did this happen? But now, once we get past the warning alarm, we can tap these guys on the shoulders, come back and say, this is an issue. And 99% of the time, that issue will disappear, won't it, Brian?
No, for sure. Look, I've just remembered another, probably 2 or 3 years ago, when we first started using this technology. There was an instance where one of the gearboxes that was normally very stable had developed like high vibration. We worked out through all the spectra that it was related to the output shaft running speed, that it was way too high, well, higher than normal. And basically what it was, we have rolls that we run on the end of our gearboxes that actually massage the steel into shape. All right, those rolls, when they wear out, they're reground to the point where they become a scrap size. So they've been ground down 10 times and they're no longer able to be used. The one that we had issues with was actually on its last grind. So it was what they call a scrap roll after that. So they were going to throw it out. Financially, the value of that scrap roll was scrap price. So they were worth, while they were running in there and causing mayhem, they were worth $140.
Okay.
All right. The machine had jumped up 400% in vibration because of the speed of that roll. So to put it into basic terms, we were trying to extract $140 worth of life out of these sets of rolls and doing $100,000 worth of damage onto the gearbox.
Wow. So consequence is always higher.
So they redid their calculations and said, all right, we won't use that size roll anymore. We will scrap it the size above.
Wow. So your condition-based maintenance is actually helping you make valuable decisions in your operational characteristics as well.
Because if you don't have an oil pressure gauge, or if you don't have a speedo in your car, it's only what you think is right, and that's right. You know what I mean? If something's there telling you something's wrong, and you're doing something wrong, that's what a rev limiter does on your car now.
Absolutely.
Don't rev it that high because you're going to cause a lot of problems.
Great.
Same thing.
So it is great to see, Brian. You've done some good work at Laverton. Greg just mentioned they're actually sort of following you in that space. If I may ask, what's the future like for this technology and CBM in InfraBuild? How would you shape that?
Okay, so just mentioning again the roles and all the variables that we have. So the next step for us now would be to include all those variables into all the data that we have, a big data sort of picture, so that we can compare apples with apples. You can very easily pick out the rotten apple if you're just looking at apples. At the moment, we've got a lot of variables and we don't really know what the causes are.
Okay.
So things like ring sizes would be really, really good to compare them against vibration patterns.
Perfect.
Speeds and feeds and things like that. Yeah, it would all be good to look at everything on one page and say, this is why it's happening.
How easy do you think it is to scale up this sort of approach? So you've done some, as we were seeing, 1,200 plus assets in Laverton, 8,400 plus bloody tests happening in this space. That's only one site. And I think if we talk about InfraBuild, there are about 5 or 6 sites across Australia. One is where Greg's sitting as well in Newcastle. How do you guys see this journey for your other sites? Because you are obviously well ahead, but how do you see for other sites?
Well, my New South Wales brothers are starting to come into line now. So Greg's been...
Is it stick approach or the value approach?
So,
is it the stick approach or the value that is coming out of the program approach?
Oh, look, the value as well, because they run the same equipment we do. All right, so there's a lot of failures. If you name out a failure, they've had it as well. You know what I mean? And if you can find something that works, then it's very easy to adopt, especially if you've done the hard yards and learnt. It's all based on time and experience, right? If you don't do the time, you can't get the experience.
Absolutely.
So yeah, even anyone wanting to start, if you prolong starting, you prolong success. There's no way that, like I say to work when I have a fairly Maltese, fairly short temperament, and I'm at any point ready to throw it in. But I do say I will be back in 2 months' time with a different T-shirt, because there's no way known now that any of these businesses could run without condition monitoring.
Absolutely. If I may ask, Brian, if I have to list, so all of these technologies we see, they're very pretty to look at. What would be one of your closest to heart favorite sort of thing from here?
Okay, so the IMX8s are my favorite. The online systems, because there's a lot of power there. There's also its little cousin now that's come out for the IMX1s, which is a single sensor wireless that sends data to the same software that we use.
Okay.
There's a lot of scope for that for all our auxiliary equipment, such as pumps, fans, things that we don't. It's not going to kill the business if they stop working. But we still do get caught out, because you might have a bank of 3 pumps. One of them's already got an issue. Now you don't have any more redundancy, so you really got to look after those other 2 a lot more closer.
Absolutely.
And if you can pick up an issue that's about to happen, it's a lot more. Yeah, you can make that original pump that was already out, make that more important to the maintainers on a down day or such, so that they get, yeah.
Perfect. Now, that's a great input. I think I'm actually getting overwhelmed myself. I'm like, how do we piece it for a organization who's still at an early step, and you've got this close to a decade-long journey behind you? So just to piece it together, let me pull in one of the industry experts from SKF, who's a PhD in condition monitoring, and also have got vast experience in sort of helping such organizations who want to embark this journey of digitalization. So let me pull in Farooq from SKF. Farooq, can you give us a brief spill, Mike? If today somebody stands up and says, you know what, Brian and Greg's done amazing work, InfraBuild's doing great in scaling up their condition monitoring program and also condition-based maintenance and the value they are generating, how would you piece it together for an early starter now?
Yeah, thanks for that, Vish. Thanks, Greg. Thanks, Brian. When it comes down to, let's say, a short and sharp introduction about myself, many of you already know me. So I've been working with SKF for 10 plus years, been driving you could say, the online condition monitoring program nationally within SKF. And then basically before joining SKF, I've done PhD in condition monitoring as well. When it comes down to particularly the design or the architecture of the system, I must say everything's been designed by keeping one word in the perspective, and that's basically scalability. So all of these products that Brian was talking about, they can be configured using smartphone, tablet, and ready to be deployed. When it leaves our premises, they are basically ready to be deployed. So no configuration required. When it comes down to data collection, so once you deploy the system, once you deploy the hardware, whatever hardware it is, depending upon portable, depending upon wireless, depending upon wired system, once you deploy that hardware, the next is data collection regime. And I must say, the application that Brian and Greg, they are talking, that's a very, very complex application because there is a lot of dynamics, a lot of process variables which are continuously changing. For example, the product type, when they change the product type, the vibrations are very, very different from product type A to product type B. Similarly, the speed, similarly, the load, the direction, all of these process variables, they have implication on the data. So the way, and I can see one of the question in the chat as well. So the way the system optimizes the data collection, that's basically in an automated process as well. So it doesn't mean that we basically need to let the operator know that we need to run the machine under this load condition or under this speed. The system automatically captures the data under likewise conditions. And why the data needs to be collected under likewise condition, it's primarily because we want to have the predictability. And if the conditions of data collections are not marrying up from yesterday to today to predict in future, then it's a challenge. So the system automatically adapts to the conditions and then filters out the data under likewise conditions for us to predict the future. Now, once we've got data in place, then where the data is going to be stored? I think that's a very important question here as well. So what we've got in SKF is an ecosystem. So for example, all the InfraBuild sites, they can be, and some of them are already connected to a digital ecosystem. What it does is it can give you some insight depending upon the operations within different sites, within different regimes. And the data that is stored onto ecosystem, that's again a question regarding the temperature data in conjunction with the vibration data in the chat as well. So when it comes down to the infrastructure, it's not only to host the vibration data, it's to hold the process data as well, inspection data as well, production data as well. And then all the analytics on the data is performed in conjunction with multiple streams of data, not only one stream of data, which is condition monitoring or the vibration data. It's all streams of data in the data analytics space. When it comes down to data analytics, from SKF perspective, we are very, very flexible. If you've got, let's say, condition monitoring team who have got let's say, in-house or on-premises resources who can conduct data analytics, we are absolutely fine. And we can be more on the support side, facilitating the infrastructure, as well as if there is anything needed to cross-validate the analytics, we can be available. Otherwise, it's readily available. Or the alternative is we can perform the whole analytics as well. So we are very, very flexible when it comes down to data analytics. If you've got in-house capability and capacity, we are fine. If you do not have, we've got an option for that as well. So that's basically kind of, I covered how the system from configuration point of view, then where the data is going to be stored, and how the analytics are performed as well. So over to you, Vish.
Thank you, Farooq. Just one more, Farooq. Previously, when I also joined the condition monitoring team in SKF and we were going on sites, in my experience, it was always looked at as rocket science before. Everybody is little, let's say, I wouldn't say worried, but little always thoughtful and concerned about getting this journey started because it's apparently a very specialist field. What do you feel now with these new apps and how the technology is evolved and how easy it is now to use? What is your take on that? Do you reckon anybody can now pick it up and use it?
Yeah, you know, Vish, I think it's the transformation, and given the current situation that we all are in, I'm pretty sure every business is basically in the transformation journey. So the technology, you could say, innovation and adoption needs to match the pace of transformation. And that's what I can see from an industry point of view. And just to give you guys one classic example, though this conversation is nothing related to commercial, but just to give one example, this sensor, which is basically in the slide, the wireless IMX1, I'm not sure, Vish, if you can put the pointer there, IMX1, the price of the sensor, just to give you a comparison, the price of the sensor is basically lower than a standard industrial general purpose accelerometer. So for example, if it's a side entry standard crystal-based accelerometer, this wireless sensor is basically more, you could say, readily from pricing perspective, from commercial perspective, it's basically more readily available as well. And then even from SKF side, one thing I want to mention here is when it comes down to deployment, previously, I know in the past what used to happen is that deploying a wired or wireless online monitoring system, it's an elephant of CapEx. It's basically a big beast of commercial arrangement. It's basically always there is a balance between how much you can spend and what value in return you're going to get out of the program. When it comes down to us, we are very, very flexible there as well. From business model point of view, we are open to CapEx or OpEx arrangement. So if you don't want to spend all the money up front, you have an option for OpEx arrangement as well. And the way OpEx works, let's say we can have a monthly kind of arrangement over a period of 5 years. What it does is it basically brings an equal investment from SKF side as well, because we're not capturing the whole lot of the revenue up front. It means that we are equally invested in the program, which means that our skin is in the game as well. So I think, Vish, that's where I can see the scalability from an industry point of view.
Perfect. Thank you so much, all, Greg, Brian, and Farooq. Before we start taking questions from the audience, I just wanted to highlight, it is amazing to see, I was just making some notes that the flexibility now it can be offered not only in the technical space, like how adaptive the technology has become and how user-friendly it is, even good to know the commercial models, they are also now very adaptable for the end user, and it's not a arm, leg, kidney anymore sort of an arrangement. It's great to know. So guys, I'm just gonna quickly shoot up in my chat box and see some questions which we've got. So just going through, we've got first one starting from Andrew. He says, Brian and Greg, this is for you. Are your tests or faults coming through from the system, coming from another system, which is CMMS or a CM database, or are you manually making a spreadsheet of these tests and faults? How do you manage it?
Greg, you want to?
From where I can understand that question, we've used what we call the one care to do that So we tie in that and our OneCare report. Unfortunately, that was the design of the OneCare report doesn't talk to SAP, so it is a manual thing. But we tie the two in together and marry them up. So yeah, whatever we do in one, we do in the other, and that way it comes off that we can actually track it through our MMS system or our OneCare system.
Perfect. Hope that answers your question, Andrew, but that's a very valid question, because right now the problem is we've got too much data sitting at too many different platforms, and platform talking to each other is a big challenge where all the APIs now work together. On that note, second one by Ronaldo, you mentioned you were using thermography both to electrical and mechanical equipment. Have you thought of replacing mechanical thermography with just a simple point and shoot laser thermometer? You can program your CM data collector to input these temperatures straight into your CM database for trending.
Not really, because we have, if you can imagine doing all those tests, we would potentially do around 400 tests in a week. So we would have to have individual thermometers or
points set up for each
one. And when we do a scan on a gearbox, we tend to know, I'm sure Greg can agree with this, that certain bearings run hotter than others. That's not what we care about. We want to know that when we walk up there now as CM techs that have been on the ground floor, you know that bearing's hotter than all the others every time.
Yeah.
The problem is if you're not pointing the laser at the other bearing on the other side that's just starting to get hot now, you're in big trouble. And that's what we do. We scan the whole thing. We know what's normal, and we can pick up very easily now what's abnormal.
Absolutely. And I think one more to add there is who is shooting the laser as well, because that's a very individual approach. Somebody standing a meter away versus somebody standing 3 meters. I think Ronaldo will be all over the shop. And just on that, Ronaldo, the other thing is now, as we are talking about automated technology, we've actually gone to a level where either you buy a thermometer, which is laser thermometer, or you buy a handheld wireless sensor that talks to your phone, doesn't only collect temperature from the casing, but also does vibration at the same time. And all of that automatically getting linked to a platform that can trend. So you're not manually entering those laser readings anywhere. So we've got there. If you want, we can talk offline and I can talk to you a bit more about that. So just moving on, next one from Mr. Bala. How are you making sure that the corrective actions are done and when? What CMMS do you use? I can answer that. OneCare.
No, CMMS is SAP.
Oh, OneCare is your CM platform.
OneCare is just our data collection platform that we have.
Absolutely.
So the best way is when you enter a job into SAP, a corrective action job, there's a category that is listed. So it's a level 1 do now, level 2 needs to be done, can't defer. They're all classed as different levels. So if it's something that can last a fair bit, then we might list it as a level 4 or whatever for a down day or a shutdown.
Absolutely. Thank you for that. Next one we've got from Hashim. Hashim asks, Brian, it was amazing to see what you've done. Reliability is a byproduct of asset management. Poor management equals poor reliability. How do you get your plant manager to buy into reliability initiatives? I see Greg laughing there. How about Greg? We let Greg answer this.
I'm a little bit more tactful than Brian in that regard, but Brian would use the "I told you so," and you only have to say that "I told you so" a few times until one, the manager says there's the front door, or he'll take it upon the fact that what you're actually giving the information for is relevant and needs to be adjusted. But yeah, so I mean, there's many ways around that, and I'll let Brian go from there.
Oh, look, what surprises them the most is when you say "I told you so" in front of their manager. It's really easy then.
That's
yeah, like I said it before, it's all about it's all about money. Doesn't matter how you want to look at it.
Yeah.
I know we mentioned it before, and my very first tradesman that when I was an apprentice said, if you look after the machines, I'll look after you. Someone else mentioned it again today. But it's not all about that. It's all about money. And yeah, I mean, everyone wants a shiny chrome machine if you want to throw $1 million at it, but if you give you $1 million and one back, they're not interested.
Absolutely.
Yeah.
It is a hard answer, because CM is a very subjective to how you actually can quantify what you do. Yes, it's a cost up front to put things in place and to learn and to build the data and the program. But overall, if you can prove that, if you could save, like I did in that instance, that's why I gave that example, a $5,000 change out of a bearing, and compared to a $100,000 rebuild, I know which one he'd rather do. Yeah, because I mean, what?
Becomes a no-brainer, yeah?
Yeah, it's a no-brainer in that regard. So that's why I use that as a bit of an example. There's multiple other examples out there. It's like I'm sitting here, I'm looking at one screen, but I've got this other screen going off that just changed the product. And I've got some alarms going off, and I'm just wondering, should I give them a call and say, hang on, let's just tweak that roll stand a little bit to see if we can get that down. So yeah, it's very dynamic. It's hard to justify to start with, and it's hard to quantify. But when you're doing stuff like this, where we can actually prevent gearbox failures just by having a screen setting an alarm off, it'll definitely pay for itself. Absolutely
adds the value. No, great. Thank you for that. Next one, I think Mark asked the question. Brian did respond on that, but I'll still reiterate the question again. So Mark says, what platform are you using to collate all the data which is being collected, i.e. some type of live monitoring dashboard?
Yeah, now thinking about the question again, it depends on which data you're talking about. If it's all the overall figures that don't really do any trending or anything like that, it's just a reporting module for numbers, then that's one key. But if we're talking about the data where it actually first ends up and where we're able to trend it and see where the problems are, so we use the Aptitude Observer software, the SKF Aptitude Observer. I also use the Enlight system to do all our handheld collections and all the shift fitter checks, the walkarounds that they do. All the data is all in one spot. Everything has a statistical alarm placed on it based on previous readings. So the minute anything goes out of line, we learn over a few months and over all our products where good should be, or where it's previously been. I mean, if a machine's been running and it's at this level, when you first start, that's good. That's a good level for it. It's not breaking down. It's where it is. If you have the luxury of replacing that machine with a brand new machine, then you can actually see where good should be if it's been installed properly, and then you can reset your levels. But anyone starting with an old plant, you just start monitoring, and whatever's still running is at a good condition.
Absolutely. So it is all about making that start.
It's all about trending what normal is for you. No one can tell you that this machine needs to do 1.4 millimeters a second or 12. Because they don't know your machine.
Absolutely. Now, thank you, Brian. Last question, a minute left, I can see. So it's again with Mark. Mark says, Brian and Greg, you have a wonderful, mature program. Kudos, guys. Farooq had mentioned predictive analytics. Have you ventured down this path and found any applications?
Yeah, Brian, go ahead.
Oh, look, I can predict when the alarms will be broken by which crew is on, if it's day shift or night shift. I can do all those predictions.
Yeah, in the way, let's say, Brian's system is set up, is basically, it has got that based on the product type, the alarm levels are adaptive as well. So it has got that, you could say, agility when it comes down to refinement of the alarm levels based on the actual product type. But nevertheless, when it comes down to InfraBuild's more from futuristic side, the vision that Brian painted, that what they want to see on the future is basically having multiple data streams be sitting onto the big data, Brian. That's what you mentioned. So when it comes down to that big data, the analytics can be performed in an automated space as well. And that's where we are leading towards, is that we have got a few pilot initiatives when it comes down to automated diagnostics and prognostics. What it does is you basically get data from multiple streams, and then you get the maintenance historical data as well, maintenance data as well. And then the way it works is you basically perform the analytics, not only the dynamic data, which is condition monitoring, but also the process data. So multiple streams of data, you perform the analytics. And the model that we build, it's not only rule-based from analytics-based point of view. The models are basically based on the rules, as well as based on what is basically the history of the data. So data-driven model as well as rule-based model, they basically work hand in hand, which perform into the analytics. So if there is, let's say, the conversation mark that you want to have further in detail, we can perhaps take it together with Brian, Greg, myself. We can take it offline as well. Or if you've got, let's say, further question to go a bit deeper, feel free to come on the voice, and I'm happy to stay around as well.
Sure. Thank you so much, gentlemen. On that note, I see we are at 2 minutes over. So thank you so much for your great input, guys. Great insights. Lovely to see how a CM program can add such great value to operations, and how important it is to actually work in collaboration with process and operations. That's the key learning, what I see from here for all. So on that note, thank you, everyone. Lovely questions. Thank you all the audience. And I hope we had some value today. If anybody wants to connect with us, feel free to approach us after the call. And what we'll do is we'll make this recording available for all of you to sort of revisit. And anytime you want to refer, kindly please do that. On that note, everybody, please have a lovely day and be safe. Thank you so much.
Thank you.